class we cover section 6.3 polar coordinates. So we're going to start by writing two definitions, but before that, let's just compare quickly what is a polar coordinate system. So what we've been doing so far, all the graphs have been graphed in the rectangular plane, the XY Cartesian plane, whatever you call it. So rectangular. And so we've been let's say plotting points, right? And they have an X and a Y coordinate. So when we talk about the polar coordinate system, it's going to have, just like the rectangular has an origin, the polar coordinate system will have like a dot, and that would be called the pole. And then we will have circles. And then each circle is going to represent a radius. So for example, the first circle, the radius will be 1. For the second circle, the radius will be 2, and so on. So that's radius 3, radius 4. However, if we're going to start by just plotting points, then we will, in section 6.4, we'll plot some graphs. With this ones here, we're just going to be graphing like a dot, just points. Something like that. So what we're going to call we already said that, the origin, instead of calling it the origin, we'll call it the pole. And what we usually refer to as the positive x-axis on the rectangular plane, or the rectangular coordinate system, we will refer to as the polar axis in the polar coordinate system. Okay, so yes, do we see the similarities there? All right, now when we graph things in polar form, we do not need x and y. What we need is r for radius, and we need an angle. So we'll use theta to denote that. So those are the first two definitions I'm going to write here for you, and then I need you guys to copy them word by word. So first we have r, and r is a directed, so that means it has direction. So it could be positive or negative, just like vectors. R is a directed distance from the pole to a point. In this case, we'll use capital P. So a point like this one here. And R being the distance from the pole to the point, so it will be here. And now, since we're seeing that it has direction, we're also going to add that R can be positive, negative, or 0. And if R is 0, then we're talking about a point at the origin or the pole. Now, theta is going to be an angle, of course, from the polar axis. So that's comparable to the positive x-axis. It also follows the definition of a standard angle in standard position, right? Positive axis. And the polar axis to the line segment from the pole to the point P. Okay, and so this angle can be measured in degrees or radians. And of course, we could have positive angles, which are counterclockwise, opposite direction of the clock, or negative, and that will be in the same direction of the clock.
So is it sort of like a radar thing?
Like a what? A radar?
Uh-huh.
But yes, if you follow the dot, yes. Okay, so do you guys need more time to copy all that? Raise your hand if you're still writing. Okay, so now let's see how we're going to use that to graph little points first. Okay, so we will refer to the point using the radius and the angle. And so first we're going to graph this example, example A. And so for that one, we could see that the radius is 2, so it's positive, and then the angle theta is 135 degrees. So if we have the angle, like we said, starting from the polar axis, which is here, okay, and we go from there in the positive direction, so counterclockwise, that's 135, which is 90 plus 45. What would that be in radians? 135. 3 pi over
4. 3 pi over 4.
3 pi over 4, yes. So, and then, because the radius is positive, we just count 2 circles from the pole. So it will be 1 and 2. So the actual point that we're graphing is only, this is just to help me out, okay? So it is only the red dot. That's the whole graph. Okay, now what happens if I tell you, and use another color, if I tell you to graph the same, but to make the radius negative? So let's see. So we will have the same angle, but because the radius is negative, we will go in the opposite direction of the terminal side, like in this direction. So the radius will be a 2, but like reflected across the origin or the pole. All right? So that point in my case, the one in green, is the one with the negative radius. Okay, now, and that is what we have here. So whenever R is positive, the point will be on the terminal side of the angle. But if the radius is negative, the point will be along the ray opposite the terminal side of theta. So it's like the reflection. Okay? And then if R is 0, like I told you previously, the point will just be at the pole. All right, so let's graph part B now. And first, we're going to identify the angle. You can see it here already. So we start here. This is the positive x-axis, which we should call the polar axis. And then we go 3 pi over 2, which is here. What is that in degrees? 270. And then, if R was just positive 3, then the point would have been located here at the third circle. However, we have a negative 3, so that will not be the point. It's going to be reflected across the origin, and it's that one right there. Here. Okay, let's look at the last one. And here we have a negative angle. And so, but we still start from the polar axis or the positive x-axis. However, we go in the clockwise direction, so negative pi/4 will be there. So this is the terminal side of the angle. And for the radius, if it was 1, the point would have been here. However, it's -1, so it's going to be reflected here across the origin. Okay, so now for the next 3 points that we have there, the checkpoints, I'm going to have you guys graph them with your partner on the paper that I provided you. So,
They're different.
okay, so I want you to use this side first.
The one with the more or
The one that has like the
less widest?
less circles.
Lesser? Oh.
Yeah, they look wider.
Okay.
Look. Example 1, and then here you will graph A. What are the coordinates of point A?
3 and 315.
No, the checkpoint. The one that you guys have checked on. Oh, 315, okay. Okay. And then, of course, write down what beta is, and then what R is. And you're going to keep this paper stapled to your notes so that you can study, because these are going to be very easy questions on the test, but if you don't ever review your notes, you will more than likely forget it, because this is the first time you have heard about polar coordinates, right? What? Yeah, because they're
Oh, because it's 3.
So first find the angle. Yeah. Okay, I'm gonna check the answers if you're still graphing, continue, but if you got one wrong, please correct it on your paper. Okay, so first one. We start here in the polar axis, positive angle, so we go counterclockwise. 315 is going to be exactly, and I'm going to go ahead and go on the third circle since I already see a positive 3. So this is the first, second, and third. So from here, I will follow it, and I'm going to stop 45 degrees before I get to 360. How do I know that? Because 360 minus 45 will give you the 315. So it will be there. However, to graph our point, we don't need all of that. The only thing we need for the point is here, that red dot. That's the only answer to it. Everything else is just helping us to find it. Okay, now the next one, we have, you all know where pi is, and if r was a positive 2, we will have something like this, right there, stopping there. And then, because it's a -2, instead of being here, it will be reflected across, and so it will be here. That's right, if you guys got it right. Raise your hand. Okay. If you did it, it's okay, just fix it. Okay, and then for the third one, we have -pi/2, so we start in this direction, clockwise, and so that will be here. And if the radius was +1, the point will be here. However, it is -1, so it goes to here. So that is the correct answer.
Wait, what was it?
So instead of being here, it gets reflected across the origin or the pole, I should say.
Is it gonna get harder than this?
The first, then you just, there you go. So that, the answer for that one is just that. I know that pi is here, but we're talking about a negative radius. So it's like a vector, when you multiply by a negative scalar, it switches its direction. So the radius can have direction. That's why it can be negative. All right, so any more questions before we move on to the next? Okay, so let's go back to the slides. And let's go to the next one. And so we're going to go over multiple ways to represent the same point. And I will tell you with 100% certainty that you will have a question just like this on your exam. Yes. Exam question. Is it going to have the same numbers? Of course not. But if you get it wrong, it's just because you are not really paying attention to what I tell you to study. Okay, so what we need to do, we could do two things. We could add 2 pi or 360 to theta, just like it says here. That's how we can represent the same point. Right? Because if we add a complete rotation, it will take us to the same point. So that makes sense, right? We keep r the same. The other thing we could do is we could add only pi or 180 to theta and replace r with -r. So we will change the direction of the radius. So that's another way to do it. Okay, so exam question, I'm telling you exactly what to do and how, and now we're going to practice. So let's see. For part A, we're going to do what it says there. So we have a point, and I will give you a question exactly like that, like no tricks. I will give you a point, and I will tell you to graph it by finding those 3 different ways. So the first one, I want my angle to remain positive. So the original point has r equals 2, and theta is equal to pi over 3. So for part A, I want to keep the r positive, and then I want the angle to be bigger than 2 pi, but smaller than 4 pi. So we're going to follow the first rule or steps. So the angle theta, and please write all this. We all know you don't have photographic memory. Theta will be pi over 3 plus 2 pi, or pi over 3 plus 6 pi over 3, and that is equivalent to or equal to 7 pi over 3. So for that point, and you're going to graph it, on this side, so you will write example 2, multiple representations of the original point that was, what was it, 1 or 2? 2? Mm-hmm. 2, 1/3? Okay. So then here we'll have A, which will be the point 7π/3, and with the same radius. So what do we change here? You might want to write down again that we did the π/3 plus 2π. That's how we got the new angle. And that point will be exactly at the same place. Okay, the next one that we have here, it says R is negative, so we'll make R negative. And then what, according to my rule here, what do I need to do to theta?
At 180.
At 180, or in radians, pi. So this is π/3 plus 3 π/3. So that is 4π/3. So let's see if it's true. So in this case, we made R negative, and this is 4π/3. And how do we get theta? By doing π/3 plus pi, remember? And so if we find 4π/3, it's going to be, here is 1π/3, 2π/3, 3π/3, and then 4π/3 right here. The radius, instead of being +2 over here, is going to move across. Let me erase all this stuff I have. Okay, so that is 4π/3, right? We all agree? Yes? Now, instead of, if R was 2, the point will be there. But R is -2, so then it's going to be reflected across the pole. So it will be here. And yes, it works. Now, you and your partner are going to figure out how to express C. And for C, what we know is that they want us to have R positive, so it's still 2. So you need to figure out what theta will be, but it needs to be a negative angle.
Oh.
So look at the point. Don't say it out loud. Word for Jeremy. And look at the point and see what angle could work. And let's see if you can come up with an equation for it. Negative in radians.
Radians?
So we want it to be here, but we want negative angle.
This is pi over 2. This is pi over 2. And this is big pi over 2, and then the difference. Yes.
So remember, the negative angle goes in this direction, guys. We start here, and then we're going to go all the way here. So what is that going to be in negative?
Oh, okay. Negative 300, right? Negative 300 degrees? Or,
Yes, in degrees, yes.
Negative pi over 3.
yeah. No, wait.
Yes, it is negative 5π/3. So how can we find that numerically? So you have pi/3, and you can subtract 2π.
Yeah.
And so that will be pi over 3 minus 6 pi over 3. And so that is negative 5 pi over 3. So that's the answer. So negative 5 pi over 3. So when you guys study for your test, you have to study this question. And you have to maybe get another example and try it out. And follow the same steps. I could send you the link of the graphing paper if you want.
And say if we put it in like degrees, would you still take it or?
Well,
Does that have to be radian?
that would be like a little technicality. So since we are saying here like radians, then you should just keep it with it. Especially for my math. Yes. If you subtract that from pi, only 1 pi. So that would have given us negative 2 pi over 3.
Yeah, put that on the other.
So we could have done, and then switch it to the other side. Yeah, that will also be valid, but because they told us to keep R positive, yes. But that will be actually it's very good. If we do, let's see, which one is not as messy. So the angle was going to be negative 2 pi over 3, right? So if we do that, that will be here, here, okay? So that's negative 2 pi over 3, like if I go in this direction. And then we will have to make R negative 2, and yeah, that will also be another good representation.
Isn't there like a lot of ways you could do it?
Yes. How many?
6.
Infinitely many, because we could always keep adding or subtracting 2 pi. Yeah. Okay, or pi. All right, so many different ways to represent that. But you still need to pay attention to the conditions. Like, do we want R positive or negative? Do we want R positive or negative? So we need to pay attention to that and the angles, of course. Okay, so let's go to the next one. And here, what we're going to do is convert from one type to the other type. And so, of course, they're all related. In fact, we could draw an XY plane and say this is the origin, and then we could transpose a polar coordinate plane on top of it, and it will be the same thing. Like we could graph the exact same things, but the equations or the coordinates will be given different. Okay? So how do we go from one to the other? Well, those 4 formulas are the ones that we're going to be using. So the first 2 are to go from polar to rectangular. And then the second, the third and 4 are to go from polar, from rectangular to polar. So let's see where the formulas come from. And we know since chapter 4 that the cosine of an angle with a radius different than if we talk about a unit circle and we move on from the unit circle, so it doesn't matter what the radius or the hypotenuse is. The cosine will be given by x over r, or adjacent over hypotenuse. So if I ask you to solve for x, you take the r across, right? The r is divided here, so if we take it across, it's going to be multiplying cosine. So r cosine theta equals x, which is what we got there. Then we do the same thing for sine. So sine of theta, you already know I'm going to say y over r. So if I want to solve for y, take this across, so it's going to be multiplied, so r times sine theta, that will equal y. The next one, it could be compared to, for example, it reminds me of the unit circle. or just a circle, the equation of a circle with the center of the origin, or also the way that you will find the hypotenuse, right? If r was like, if you put it in terms of a squared plus b squared equals c squared. See, so a lot of formulas, I would say. And so we're going to use that to find r, this one. And then this one to find theta. Okay? So first one, we're going to convert from polar to rectangular. So we're going to use our first two formulas to find x and y. Okay, so here we have that r is equal to 2, and then theta is equal to 3 pi over 2. So what is the first formula I need? Formula number 1 from that table. X equals r cosine theta. R cosine theta. So that's going to be 2 times the cosine of the angle 3 pi over 2. And that will equal to 2 times the cosine of 3 pi over 2. Isn't it 3 pi over 2 here? Oh, sorry, the other direction. There, right? So what is the cosine there? -1. So the cosine is the x value, so it's 0. So what will this be? 0. So what does that mean? That x equals 0. Okay, now let's find y. So y is going to be r sine of theta. So that will be 2 times the sine of 3 pi over 2. So then, once we get the numerical value of sine of 3 pi over 2, that will be -1. At that point, guys, we do not use sine anymore. You guys did that a lot on the exam, on exam 2. Like you had the ratios, but you were still using sine or cosine. So in this case, the answer is -2. So that means that y equals to -2. Now, let's see if this is true. So if we plot that point like that, in rectangular coordinates in xy plane, it will be 0 for the x and -2 for the y. Now, on your paper, let's graph it. So for that one, I want you to graph it on the other side. And we're going to use, in this case, we're going to use the 2 that are here on the first row. So those 2. So this will be example 3. And the point, we're going here from polar to rectangular, right? And so in polar, the point was, what was the radius? 2. So let's see if we can graph that in polar. So 3 pi over 2, so it is here, right? And then we count 2 circles, so the point will be here. And so if you compare it to the rough sketch that we did of the point in rectangular, which was 0, -2, it was right there, right? Yeah. So same thing. All right, let's do the other one. Let's plot it first. So our next point is -8, and then pi over 3. refract. So in polar, -8 and then pi/3. So let's see. Pi/3 will be from the polar axis to here. And then we are going to count, instead of +8, so we're not in this direction, we're going in the opposite direction. So it will be this line actually. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Okay. And then in rectangular form, let's see where we're going to get when we do that. So we got to do that numerically. And then you guys can go to break after. Okay, so we have r is equal to -8 and theta is equal to pi/3. So for x, we use r cosine theta. So that will be -8 times the cosine of pi/3. And that will equal to -8 times the cosine of pi/3 is the same as the cosine of 60, which is the sine of 30. What's that number? Half.
So, like the 4.
So -4. So x is equal to -4. Now let's see what y will be. So y is r sine of theta. So that will be -8 times the sine of pi/3.
Square root of 3/2.
That's the square root of 3/2. So here we could reduce the fraction. So -8 divided by 2 is -4. So -4 times the square root of 3. And that one approximately is like, someone told me earlier, like -6 point something something. So if we were to graph that in coordinates, rectangular coordinates, it would definitely look like something like that, like 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, somewhere over there. Okay? So what was that? -4, comma, -4 times the square root of 3. Okay, so I'm going to pause the video now.